So for today, exponents, we're still dealing with exponentials, right? We're solving them now, solving them. Okay, we've solved equations all year long. Since August, September, October, we've always solved equations, different types of equations. But these are exponential. So what does that mean? It means the variable, the x, is the power, right? Like for example, that guy, that's not an exponential. Okay, it's got an exponent, but it's not an exponential because the x is not the power, right? If I switch them, that's an exponential because the power is up, power is the variable. Okay, so that's the kind of thing we're going to talk about today. Okay, so for today, the big idea is this: if two bases are the same, then their powers have to be the same as well. Okay, if bases are the big number, right? Base is the big number. Base, and then exponent is the little guy in the sky. Okay, so if you have two bases that are the same, the exponent has to be the same as well. 1a. Bases are the same, right? I have a base of 4 and a base of 4. So what has to be the exponent? What does the exponent have to be for the second one? 2. Has to be 2. Can't be anything else. It has to be 2 because they're both the same. Right? Everything has to be the same when they're equal. Okay? But then you get to a question like B, where they don't have the same base, right? 2 and 8 do not have the same base. But what we're going to have to be a little creative today. Is there a way I can change 8 so that it has a base of 2? Now, I don't want to say change the number, leave it 8, but instead write it differently. Is there a way I can change the way 8 looks that would make it still 8, but written differently, written with a power? 2 to the third power, right? 2 to the third power. Still 8. 2 times 2 times 2, still 8. That hasn't changed, right? But now it has the same power or base. It helps me solve it, right? So that means this guy has to be a 1 to make it work because we multiply powers, right? Power to a power, we multiply the powers. So 2 to the third equals 2 to the third. Right? That's more of what we're going to be doing today. Changing the way it looks so that we make them equal. That's our first step. Our first step is make the powers match. Rewrite it, the problem so that the powers match if they don't match to begin with. That's the hardest part about today, step 1. And it's not really that hard. It's just sometimes it's a little tricky. Okay? Once we do that, we simplify the exponents, and then we set the exponents equal to each other and solve. Okay? So let's look at step 1, or number 1. I have a base of 2 and a base of 16. They're not the same. 2 and 16 are not the same. But is there a way for me to write 16 so that I have the same base as this guy? 2 to the fourth power, right? 2 to the fourth power, 2 times 2 times 2 times 2 is 16. I didn't change the number. I'm not changing any numbers. I'm just changing the way it looks. This guy already has a 2, so it doesn't need any changing. So I rewrite everything the way it is. Now they have the same base, 2 and 2. Next step is simplify the exponents. So one of the exponents has one of these guys has parentheses. So how do we get rid of parentheses? Remember, how do we get rid of, we did them a while ago. What do I need to do to get rid of parentheses? What's the rule? Let's see, where are my rules at? Right here. Right, exponent rules. For parentheses, if there's more than one thing in here, you distribute the power. If there's only one thing, you multiply the powers. You distribute the power, right? So that's what I need to do. I need to distribute 4, because 4 is on the inside. I'm going to distribute to these guys. First one doesn't change. It stays the same. Didn't need to change. The second one becomes 4x plus 12. Bases are the same. So by rule, if the bases are the same, the powers have to be the same as well. So let's set the powers equal to each other and solve for x. Okay. So if I'm solving, first thing I got to do, put a line in between. I get to get the x's together. Bring everything down I haven't used. Subtract 4 from both sides. Negative 2x equals 8. Divide by negative 2. X equals negative 4. There you go, x by itself. So x would have to be negative 4 to make that true, to make both sides true. If I plug in negative 4 here and negative 4 here, negative 4 plus 3 is negative 1. Negative 4 times 2 is negative 8, plus 4 is negative 4. So what it's saying is 2 to the negative 4 power is the same as 16 to the negative 1 power. That's all it's saying. Okay. All right. Letter B. Bases are not the same. 27 and 81, they are not the same. But do they share anything in common? Can I change one, or can I change both of them so that they have powers that are okay, that match? What's the only way to write 27 as a power, with a power? What to what power? Like 2 to the 3rd power, 3 to the 5th power. What's the only way to write? There's only one way to write 27 with a power. 3 to the 3rd power. Yeah, that's the only way. 3 times 3 times 3, right? I can't write 27 like 4 to the 3rd power, 5 squared, close to 5 squared, but it's not exactly. 6 squared, 7, those types of things. I can't, the only way I can write 27 is 3 to the 3rd power. Can I rewrite 81 with a 3rd power? Yeah. 3 to the 4th power is the same as 81. They're still the same number. I just rewrote them with powers instead of just 27 and 81. Okay, they got the same base. Distribute the exponents. Distribute the exponents. 3 to the 3x plus 3 equals 3 to the 4x minus 12. Okay, bases are the same. Once the bases are the same, I can set the exponents equal to each other, because by rule, those have to be the same as well. Okay. You can subtract 4x or you can subtract 3x. It doesn't matter. Either one's okay. Oops, not 15, 12. As long as you get x alone on one side and you get everything else alone on the other side, you're good. Okay. So the big hump to get over is step one, changing the powers, changing 27 to be 3 to the third, changing 81 to be 3 to the fourth, making them the same. That's the big thing. Once you get there, the rest of it, you guys have done millions of times before. All right. Okay, so let's go to the back. Letter C. Same direction, solve, but now one of them's a fraction. Go back a few lessons. How do we change fractions? Or when do we get a fraction? What power gives us fractions? What type of powers give us fractions? Negatives. Yeah, remember negatives? Negative power give us fractions, right? Those are the guy that gives us fractions. So this guy here is going to have a negative power. Okay? Well, 9 to the negative 1 is the same as 1/9. 9 to the negative 1 is the same as 1/9. Is there a way for me to write 81 so it has a base of 9? 9 to what power? Squared. Yeah, 2 power. Negative 1 power just means move it to the top, move it to the bottom. Leave it the same. So negative 1 power just meant move this guy to the top. Don't have to change it, still 9. And then 9 times 9 makes 81. Okay, so I'm going to distribute the powers to get rid of the parentheses. So 9 to the negative 5x plus 3, 9 to the negative 2x plus 28. Powers are the same, or sorry, the bases are the same. So if the bases are the same, that means the powers must be the same. So I'm going to set them equal to each other. Okay. Let's see, add 5 to both sides. Again, you can add 5 to both sides, or you can add 2 to both sides. Either one will work. Okay. Divide by 3. It's going to give us a fraction that can't be divided. It's okay. We can have ugly answers. It's okay as long as you did everything right. So just if you get an answer like that, just double check that you did everything correct. If you did everything correct, leave it like that. Your answer, negative 25 thirds. Don't change it to a decimal because sometimes Delta Math doesn't like decimals, especially when your decimals are long decimals. If it's like 0.5, 0.25, that's okay to change it. But 3, if you divide by 3, it's going to be like 0.3333333 or 0.6666666. It's going to be long decimals. So just leave it as a fraction. If you can reduce it, reduce it. But 3 doesn't go into 25. So can't do that. All right. All right, so now we have a fraction and 2 big numbers. A fraction and 2 big numbers. 729. What to what power makes 729? I know it's got to be negative. So the way you do this is just you go to your calculator. It's good old guess and check. You go to your calculator. I got to make 729 using a power. $7.29. So it's not going to be 2 to any power because it's an odd number. So let's see. 3 to the fourth power. Nope. 3 to the fifth power. Nope. 3 to the sixth power. Ooh, 3 to the sixth power works. What's the other number? 287 or 2,187. Is there 3 to any power that makes that? Yep. So it's going to be 3 to the negative 6 because 729 is a fraction. 3 to the negative 6 and 3 to the positive 7. Okay. Distribute. So 24x plus 12 when I distribute negative 6, and 14x minus 49. Bases are the same. So that means exponents have to be the same too. So I'm going to set the exponents equal to each other. 24x plus 12 equals 14x minus 49. Okay, solve for x. Negative 61. Divide by 10. Again, it's not going to go in evenly. So just leave it negative 61 over 10. Because can't divide 61 by 2, by 5, by 10, so can't reduce it. I don't want to change it to a decimal, so leave it the way it is. All right. Okay, so I want you to do letter D now. Do letter D. Or E, sorry, E. Can you go back to the problem? Yep, it's right there. Do letter E. So we have 1/4 and 1/2. So they're both going to be negative because I got to flip them to make them whole numbers. So they're both going to have negative powers. I just don't know what to the negative power. Well, 4 and 2. 4 is 2 squared. So 2 to the negative 2. And 1/2 is 2 to the negative 1. So they both can be written with powers of 2. Make sure the bases are the same, and this guy right here is equal to this guy right here, and same thing here. Make sure they're equal to each other. They're the same answer. Don't change the number. Okay? So now they have bases of 2. So now I can distribute. Distribute. So I get 2 to the positive 6x plus 24. Then on the other side, I get positive 3x squared minus 15x. Bases are the same and no more parentheses, so now I can set the powers equal to each other. 6x plus 24 equals 3x squared minus 15x. So the question here is, how do I solve this? Well, it's got a squared. We've been doing this since September, right? If it's got a squared, change it to a trinomial or a binomial. Change it to a trinomial or a binomial. That's how we solve those. So get everything. Step one is always get everything on one side, set it equal to 0. So I'm going to subtract 6x from both sides. Then subtract 24 from both sides. Okay, trinomial. A is 3, B is negative 21, C is negative 24. So it says set equal to 0. Okay. Does it have a GCF? Is there a GCF between all three of these guys? Yeah, I can divide them all by 3. So we get x squared minus 7x minus 8. Once we get the GCF, whatever's left, ABC. So multiply to be negative 8, add to be negative 7. Negative 8, positive 1. Box. X squared minus 8x plus 1x minus 8. So it's going to be x minus 8 and x plus 1. This part we've done many, 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 many times. Well, set everything in parentheses equal to 0. You don't have to set x or 3 equal to 0 because they're not the same. 3 and 0 are not the same. Subtract 1 from both sides. You get negative 1 as an answer. Add 8 to both sides. You get positive 8 as an answer. Get 2 answers, 2 boxes. Negative 1 in one box, positive 8 in the other box. You get 2 answers. Okay, that's the only difference. The only difference was it was a quadratic, so we had to solve it. We had to change it to a trinomial and use those steps. We've done that before. The only new step for today that you haven't done before is the powers, is changing the way it looks, the very, very first step. Everything else you guys have done many times. Okay, so now do this guy. Do letter F. Do letter F, and then I'll give you one more problem to do on your own, and then we'll be done today. So 2 more problems. So one of the powers you don't have to change. 7 just stays 7. 7 to the first power. But the other one is 7. 343 is 7 to the third power. But it's on fraction, so I have to make it negative third power. So I just have to distribute one side. Minus 96. Okay, they have the same base of 7. So now I'm going to set their powers equal to each other. Okay, again, it's got a squared. So if it's got an x squared, change it to either a trinomial or a binomial. Okay. Trinomial, set it equal to 0, done. GCF, it does have a GCF. You can divide everything by 2. It's going to be x squared minus 14x plus 48. Okay. Now we're going to do ABC with that stuff to figure out what the two answers are. We're going to get two answers. So multiply to be 48, add to be negative 14. Negative 8 and negative 6. Negative 8x, negative 6x, and positive 48. So x minus 8, x minus 6. Okay. Set anything with an x equal to 0. So anything that has an x, set it equal to 0. 2 doesn't have an x, so I don't need to set it equal to 0. So I add 6 to both sides. I get positive 6. Add 8 to both sides. And I get positive 8. So I get two answers. Positive 6, positive 8. Two boxes on Delta Math. Okay. All right, I'm going to give you one more to do on your own and we'll be done. One more and we'll be done. Call this letter G. Okay. Okay, solve that. Okay.